In this class, we will talk about vector proximity analysis, and we will be working mapping and analyzing what's nearby or far away. We will examine some proximity analysis tools under the Euclidean distance methods. We will also do some overlay analysis. We will use a tool called spatial join. We will also talk a little bit about open source data, and we will have the experience to download data that comes from an open source, but also a crowdsourced data. So let's start talking about proximity analysis. Proximity can be measured in two ways. The first approach is a simple straight line that is also called Euclidean distance. Euclidean distance is a way to measure the straight line distance between 2 points in space. So imagine if you have 2 points, one right at the Mexican-US border, and you want to know where is a straight line point at 120 kilometers. So instead of measuring the actual path between them, you can draw a straight line connecting them to measure the length of that line. That length is the Euclidean distance between the 2 points. In even simpler terms, Euclidean distance is like measuring the as the crow flies distance between the 2 points, and it gives you a very direct measurement of how far apart the points are without considering any obstacles or curves in the path. Now, the second approach to do proximity analysis is the network distance analysis, and it's a method used to calculate the distance or travel time between locations, taking into account the actual road or any transportation infrastructure. So imagine you have to find the shortest route from your home or point A to a specific destination by car or point B. Network analysis will use an algorithm that considers the actual road network, including streets or highways and intersections, and it takes into account also factors like road conditions, speed limit, and one-way street to determine the most efficient path. So this analysis can be very useful in various scenarios. For example, it can help emergency services find the quickest route to a location, or it can assist the planning transportation networks by identifying areas that need improved connectivity. So in simple terms, network distance analysis in GIS helps calculating the most efficient path between two locations, but it will consider the real-world network and factors that can affect the travel time. So these are the tools that we will be using to calculate distances. And we're talking about Euclidean straight line distances. We will look into select by location, buffer, near, and point distance. So let's start with select by location. This tool allows you to choose or highlight geographic features based on the relationship with other features. And it works by comparing the spatial relationship between different layers or data sets. As you can see here, we have two layers, one in green and another one shaded. So imagine you have two sets of data. One can be representing the locations of parks and another representing the locations of schools. So with select by location, you can ask the GIS software to find all the parks that are within a certain distance from schools. So select by location helps you identify and highlight specific geographic features based on their spatial connection to other features. So in simple terms, select by location in GIS is like filter that lets you choose and highlight certain maps elements based on their location and how they relate to each other. It helps you find features that are nearby or within a boundary or intersecting with other features, and enable you to analyze and work with specific data sets or parts of those data sets. Then we have the buffer, which is one of the easiest tools to understand and one of the most commonly used. It is quickly an easy way to determine both if and how much or how many features are found within a certain distance of another feature. For example, if you were trying to figure out how many homes fall within 10 miles of an ambulance station, you could use this tool and a combination of buffer and select by location to answer the question. You could probably do it by using select by location only, but this is an option that you have. If you want to graphically represent that buffer and the process you're doing, buffers are a great option. So the buffer tool works with an input layer, and you can see here points, lines, and polygons. And then you can just define different types of buffers, like buffers that are created based on each one of the features, or buffers that are dissolved independently of how the features, if they are connected or not, like in this example with lines. Also, buffers can be single ring or multiple ring, and they can have different distances. This is an example of single ring. We're going to be doing or performing an exercise where we calculate a buffer from the border, US-Mexico border, and this is a multiple ring buffer that helps us create different distance buffers from a selected feature. So these tools are very useful, and they are indeed heavily used in the real world. This graphic that you see here looks at the evacuation zone from the Fukushima nuclear power plant. So I want you to pause for a little bit the video if you can and look at the graphic. So in the graphic, they use two buffer zones as an evacuation zones. First, the 12-mile evacuation zone, and then the 12 to 19-mile evacuation zone. They have multiple buffers or distance from the plant in miles, as you can see right here, and the possible radiation exposure in rems. And you can see that each one of these buffers represents the possible radiation exposure for people on the right side listed here. And it follows by possible effects and also population before earthquake. So here the buffers, even though you can do a select by location without actually creating buffers, here the buffers show to visually represent these different distances and the effects that each one of the distances could have over population. So the next tool is the near tool. And one common question we ask in GIS is, what is near what? So while buffer finds all of the features which fall within a distance of the input features, we do not know the exact distance between two objects or features. So the near tool will compare two layers and create a new output field with the information of the distance from the input feature to the near feature. And the attribute table will have the exact distance between these two features. So the near tool has only one limitation, and that is that it can only find the nearest feature in another data set, meaning that there is a one-to-one relationship in the input layer. So for example, you can find out the distance from this point to the nearest feature, which is this circle, but not the distance from this same point to another feature. So it finds only the nearest distance to the next feature. So in contrast, the generate near table can find the distance between all of the input and output features. Since the generate near table finds so many distances, the output is not a layer, but instead is a table. And so the table will allow the user to examine the feature ID or the object ID of the input layer and the features in the near layer. So with this tool, you are able to find the distances from one object to many other objects. Another note to take is that distances are calculated in the units of the coordinate system. So if you're using a projected coordinate system that uses feet, all of the distances will be calculated in feet. Now the last tool that I want to describe is point distance, which calculates the distance from all points in one layer to all points in another layer. When you have multiple points, for example, in one layer and multiple points in another layer, and you need to calculate the distance from each one of the points in one layer to all of the points in another layer. Again, the distance will be calculated in the units of the coordinate system. So if the coordinate system uses meters, the result will be in meters. Now, finally, there's a tool that is a raster based. That is, it uses a feature layer vector, for example, points, to calculate the distance from points out. In this example, what you're seeing is the MBTA stations that were used to create a continuous surface, giving you the distance from the MBTA stations. So again, with this tool, and when it comes to the results, the distance is calculated as raster. So in order to imagine this, you can think about the result as a map divided into tiny square cells, like a grid. So each cell would represent a small portion of the map. In the case of Euclidean distance, the value assigned to each of the cells or pixels is the distance from that cell to the nearest target location. In this case, it's the MBTA stations. So when you calculate the Euclidean distance using GIS, you get the whole grid of values. So in combination with overlay tools, the tools found in the proximity analysis toolbox make up the majority of the tools that GIS technicians use per projects. So these list of questions such as how far is an island from the coastline, or what is the distance to all airports in a city from a power plant, are only just a few examples where you can apply these tools. Now let's jump into another tool we will be using, and this one you have already used, which is called Spatial Join, and this is an overlay tool analysis, and what it does is to join a dataset on a spatial location. So imagine that you have different maps, each one with different types of information. For example, one map shows the locations of parks in a city, and the other map shows the boundaries of different neighborhoods. Now you want to know which parks fall within each neighborhood. So a spatial join tool in GIS will help you do exactly that. It will combine the information from both maps based on their spatial relationship, which means that it looks at the geographic location. So location is the key in this particular tool. So by using the spatial join tool, you can create new maps that include both the park and the neighborhood information. So in the neighborhood, you will have the information about the park, and this will be reflected in the attribute table. So spatial join is a function that will combine the attributes of features into layers based on distance or containment. And as you can see here, we will be using always two different layers. This is a polygon layer, this is a point data layer, and you combine both such that the destination feature class, this polygon, will acquire the source feature class and combine them both so that you will be the data, or both of the data sets, reflected on the attribute table. So the output will be a polygon layer, but it will contain the attribute table from the point layer.